Welcome to my channel. This is Leo. Today let's do some more Leetcode problems. This is the shortest path to get food. So we're starving and I want to eat some food as quickly as possible. So we want to find the shortest path to arrive at any food cell. So any food cell indicates that there could be multiple food cells. So we're given a m by n character matrix grid of these different types of cells. A asterisk is your location, and there is exactly one asterisk cell. The sharp is a food cell. There may be multiple food cells. 0 is a free space, and you can walk through these cells, and X is an obstacle. This is like the wall-like thing, okay? So you can travel to any adjacent cell, north, east, south, west. So that's basically 4 directions. And if there's no obstacle, return the length of the shortest path for you to reach any food cell. If there's no path, return -1. Let's take a look at the example here. We're standing here, and the shortest path would be 1, 2, 3. Okay, so the output is 3. And also we can do 1, 2, 3, or maybe 1, 2, 3. Okay, so yeah, that's the first step. And the second thing is we can't do anything with it. So we return -1. And here we have 2 food sources. The shortest one would be this one. So we walk from here, 1, 2, 3, 4, 5, 6. We return 6. So this is like a very typical BFS problem. We can just start traversing from here, then go to the 4 directions. If it's unvisited and it's not an obstacle, we can go from here, and we can update the count as it goes forward. Okay, so let's try this one. What we need now is the m by n. So m is grid.length, n is grid0.length, and we also need a visited matrix. Boolean matrix is called visited, and it's going to be m by n. Okay. Now we're gonna traverse all the nodes in this matrix. So for j equals to 0, j is less than n, we do the BFS. Okay, we need ij, the current location, and n, the scale. Then we need the grid and the visited. Okay, so I think we can just return it as the answer. Okay, so, and if it doesn't work, return -1. Okay, so let's try to write this integer BFS. We need I, we need j, we need m, we need n, we need the whole grid, we need the Boolean matrix. So since we're doing the BFS, we are going to initialize a queue. And since we're dealing with coordinates, we have to put a coordinate here. New linked list, and we're going to offer our existing coordinate in there, and then we mark it as visited. Okay. Also, we're going to initialize the count variable for our answers. Okay. Now we can do the expansion while q is empty. Since this is a layer by layer BFS, we have to record the size of the queue in order to avoid any conflictions or duplicates. So size equals to q.size, and for int like d equals to 0, d is less than size, d++, and we can pull our existing point out. So I'm going to call it cur q.pull. Okay. And we can initialize the x for its x-axis and y for its y-axis. Okay, now like we have this point pulled out from the queue. Now we have to look at all the neighbors at this point. So for all the neighbors, who are the neighbors? They are x plus 1, y, x minus 1, y, x, y plus 1. It's pretty slippery here. Okay, x, y minus 1. Okay, these are the 4 neighbors of this point. So we only want to process the valid points. So first we have to eliminate all the invalid points, right? Before we visit all the neighbors, there might be a problem. There might be a chance that the food and me standing at the same point. So we have to do a checking here. If grid x and y, it happens to be the food itself, we should return count. Okay. Now we can traverse the neighbors. First, we have to eliminate all the invalid ones. So if x equals to -0 and y equals to -1, and if x is less than 0, or x is larger than or equal to m, y is less than 0, or y is larger than or equal to n, or maybe grade x, y is what we call a wall. Okay, so if this is the case, we're going to just continue. We'll just ignore it. Okay, now finally we're here at the point where it is a free space. So we handled okay. Yeah, I think I've missed something here. If grid ij equals to me, then we can return the BFS. Okay, so we handled the asterisk, and we also handled the sharp. Then we handled the x. Now we're handling 0. Okay, so if it's 0, we can go through it. We can do if it's unvisited, x, y. We can add it into the queue, and we mark it as visited. Okay. We pull it from here. We're visiting this. After we've done this, we can increment the count. Okay. Oh, sorry. I think I need to put the count here. When each layer is processed, we can update the count. Okay. So, still, if we can't find anything, we can just return -1. Okay. Let's run it. Oh, okay. Sorry. This should be a character matrix. Okay, I think it passed. So let's do some complexity analysis. We are traversing through all the grids here, so it should be mn. And for the space complexity, I think we have a Boolean matrix, so it's going to be n by n. And also we have a BFS. In the worst case, it's constant. So yeah, we can ignore that. So now we can submit it. Okay, I think we passed it. Thanks for watching. I'll see you in our next video.